everyone, this is Teacher Jane again, and my lesson for today is all about union and intersection of events. If you haven't subscribed to my YouTube channel, please click subscribe and don't hesitate to ask questions by leaving a comment in the comment section. The easiest way of illustrating union and intersection is through sets. So I have here the most common tropical fruits in the Philippines. So these are the set of fruits. I'm going to show you now how sets interact with each other. So we call them operations on sets. So therefore, I'm going to choose fruits and I'm going to place them in these two baskets. So these are the fruits that I'm going to place on the first basket and the fruits that I placed on the second basket. Let's call the first set of fruits, okay, as your Monday fruits, or the fruits that you're going to eat on a Monday. Okay? And of course, the second basket shall be called the Tuesday fruits, or the fruits that you have eaten last Tuesday. The first operation of sets that we are going to learn is what we call as intersection of sets. So I have here the Monday fruits, or the fruits that you ate last Monday, and Tuesday fruits. Okay. So what are we going to do now with the third basket? Of course, we have to put the fruits, okay, that we feel is an intersection of your Monday and your Tuesday fruits. So starting with mango. Okay, because on Monday and Tuesday, okay, it's a common fruit that you were able to eat. And of course, kaimito. And last would be santol. Okay. So when we say intersection, these are the common elements in both set A and set B. So the common fruit that you ate on Monday, last Monday and last Tuesday were mango, santol, and kaimito. Remember that sets have to be distinct. So there's only one santol, one mango, and one kaimito. So it has only three elements. So we can write this as M intersects T, or M intersection T. M, which stands for set A, or your Monday fruits, and T, which stands for the Tuesday fruits. Or another way of saying this is M and T, for Monday fruits and Tuesday fruits. So meaning these are the common fruits, okay, or the common elements taken from set A and set B, meaning they're both in set A and set B. The second way of operating sets is what we call union of sets. So again, I have this third basket in the middle. And what do you think are the fruits, okay, that we are going to place in our third basket for it to represent as the union of the Monday fruit and the Tuesday fruit. So these are the fruits that we're going to place in our union basket. So we start first with the common elements, mango, or the common fruits, kaimito, and santol. Remember, the common fruits, okay, is counted are, or they are distinctly placed in the basket. So there's only one santol, one kaimito, and one mango. And the next thing is we have also to get all the fruits that are in the Monday basket. Balimbing, lanzones, mangosteen, banana. Make sure that our set A, or Monday fruit basket, is empty. Then we are going to get all fruits now in our Tuesday basket. We have avocado, rambutan, strawberry. So all in all, our union basket would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fruits all in all. So this is now what we call as M union with T, or the Monday fruits rather, union with the Tuesday fruits, or we can say M or T, meaning Monday fruits or the Tuesday fruits. So when we use union, it means all the possible fruits have to be placed in the basket, which includes also those fruits that are intersecting or common. Then you add those that are not common. In mathematics, sets are defined to be a collection of distinct elements. So when you say distinct elements, every element of the set have to be unique. So there shouldn't be any repetition. So let's take now the following examples. Okay, taking set of real numbers. So let's have the first one. The positive integers less than 6. So let's call that set A. And let's identify the elements that are positive integers less than 6. So we start with 5 because it's less than 6. 4, 3, 2, until 1 only, because 0 is not positive nor negative, and after 0 are already negative integers. So this is now set A, which is distinct, meaning all the numbers are unique. Now let's have example number 2, the set of odd numbers from 1 to 4. So let's call that set B. Okay, and let's write the elements that are set of odd numbers from 1. So 1 is an odd number, 3, 5, 7, until 9 only, because 10 is an even number. So it has 1, 2, 3, 4, 5 elements as well. So this is how we write sets. The first operation on sets that we are going to learn today, using the set notations that I've given in the example, would be the intersection of two sets. So what is an intersection of two sets? It's the set of the common elements on both sets A and set B. So same thing with the fruit basket that we have done. So we are going to pick what is common in set A and what's in set B. So let's have this first example, the set of positive integers less than 6. Let's call it set A. So the elements are 5, 4, 3, 2, 1. And of course, we should have set B, the set of odd numbers from 1 to 10. So we have 1, 3, 5, 7, and 9. So since we want to find out A, okay, intersection B, or A intersects B, what would be the elements of A intersect B? So let's just check what is common to both A and B. 5. Okay, it's also in B. So we have to list 5. Okay. 4 is not in B. It's only in A. 3, okay, is in A and B. So we have 3. 2 is only in A. 1 is in A and B. So these are the elements of A intersection B. They are 5, 3, and 1. So there are only 3 elements. The second operation on sets is, of course, the union of sets, which means that the union of two sets is the set of all the elements in the collection, meaning the set of all the elements coming from set A or set B. So let's have again this example, set of positive numbers, okay, less than 6. These are, so let's call this set A again, okay, 5, 4, 3, 2, 1. And set of odd numbers, let's call it set B, from 1 to 10, we have 1, 3, 5, 7, and 9. So unlike intersection, okay, union has to have all, okay, the elements from A or B. So let's write now A union B. Okay. Since we know already that A intersection B has the elements 1, 3, 5 in my example of intersection, then we are going to include now the elements from set A, which is not 1, 3, 5, because we already listed 1, 3, 5, and these elements are 4, 2. So same thing with set B, we already listed 1, 3, 5, 4, 2, and we only have 7 and 9. So we have now the set represented by A union B. So I hope that you're able to differentiate an intersection to a union. So when you say intersection, all you have to do is get the common elements from set A and set B. While if it's a union, you have to get all the objects in both set A and set B, including the intersection. Another way of illustrating union and intersection, and actually I find it the best way, is through a Venn diagram. So if we are going to list the positive integers less than 6 in a Venn diagram, it will be listed in a circle, and we write there 1, 2, 3, 4, 5. And in the next circle are the odd numbers from 1 to 10, so we write 1, 3, 5, 7, 9. To make it into a Venn diagram, of course, we have to illustrate their intersection. Okay, so this is what will happen. 1, 3, 5 is the part, okay, that represents the intersection. Okay, let's call it A intersect B. So this is that part. Okay, and the part that represents A union B, okay, A union B will be the whole part. Okay, so everything. Okay, the uncommon elements 2, 4, the common elements 1, 3, 5, added to 7, 9. So, this is how we illustrate A union B, or the odd numbers from 1 to 10, okay, or the prime numbers from 1 to 10. So, this is now Venn diagrams, intersection, and union. Now, let's apply now Venn diagram. Okay, now I have this data that shows the number of students who still watch TV and those who do not watch TV anymore. So I have 15, okay, 19 rather, sorry, who watch TV, 23 who do not watch TV, but there are 8 students, okay, who watch TV sometimes and do not watch TV sometimes as well. So it's actually the intersection. There are 8 students, okay, who watch and do not watch at the same time. So this is how the Venn diagram works. Now let's apply this knowledge about Venn diagram with this problem. 30 selected grade 10 students were asked about their preferred cell phone brand, and the result is shown in the Venn diagram. So there are two brand names, Oppo and Huawei, and this was the data. So there are 11 who favors Oppo only, 4 A who is unsure whether Oppo or they both like Oppo and Huawei, and 15 for Huawei only. Now, let's have the first question. How many students prefer Oppo brands? Okay, sometimes there's a common mistake that students will answer 11. Okay, but the real answer is there are 15. Remember that the intersection part here, 4, there are also 4 students who prefer Oppo brand. Okay, aside from this 11. So you have to add 11 plus 4, so there are 15 students. Let's have the second question. How many students prefer Huawei brand only? Okay, so Huawei brand only, some students would answer 19 because 19 students, okay, favors Huawei. But because of this word only, it means those 4 students who prefer Oppo at the same time should not be in our favorable outcome. So we only have 15 students, this part only. Last question. How many students are unsure of their choice? Obviously, these are the 4 students, okay, in the intersection part. So there are 4 students who are unsure whether they like Oppo or Huawei because their choice is both. I have already shown you that union and intersection can be done with sets and in Venn diagram. But today, I'm going to show you also that union and intersection can also be translated in events. So let's recall first what is a compound event. A compound event is the composition of 2 or more other events. It could be formed by a union or intersection of 2 events. But there are other forms, okay? There are other form of events that could come up as a compound event. But for now, since our topic is union and intersection, then our focus would be compound events formed by union and intersection of two events. So simply, the sets will be translated into an event. So let's start with intersection first. So there are two events and we want to find out its intersection. So intersection of two events. So the intersection of events A and event B are denoted by A intersection B. And it is the collection of all the outcomes that are both on sets A and B. So it's the same thing. We have to collect the common elements, okay, in both sets A and B. So it corresponds to the combining description of two events using the word and. Okay, so it means the word or the conjunction and only means that they are both in set A and B. So let's have this experiment. So since it's an event, we always have to start with an experiment. So rolling a single die, and we want to find the intersection of A and B events. So this would be our event A. The number rolled is even. Okay, meaning getting the number that is even when you roll a die. Okay, and event B would be the number rolled is greater than 2. So we have event A getting an even number and event B getting a number greater than 2. So we already have now two events and we want to find its intersection. First, let's write the elements, okay, of event A and call it set A. So, do remember that when you roll a die, these are the following possibilities, okay, or outcomes. We have 1, 2, 3, 4, 5, and 6 only. Okay, so the number rolled is even. So, 2, 4, and 6, okay, are even. So, let's write here 2, 4, 6. So this would be event A or the favorable outcomes in event A. Now, B, the number rolled is greater than 2. So the number rolled greater than 2 would be 3, 4, 5, 6. So list here 3, 4, 5, and 6. Next is we are now going to find out the elements of A intersection B. Remember, it stated that the elements have to be both in set A and set B, or the common element 2, okay, is not in set B. 4, it's in set A, in set B. So our first element will be 4. 6, okay, it's in set A and in set B. So we only have two possible outcomes, favorable outcomes. We have 4 and 6. So that's how to show intersection of two events. Now, the second one is what we call as the union of two events. Okay, so the union of two events is a collection of all outcomes, okay, or the elements of one or the other of the sets A and B. So meaning it's the same as the union of sets. You are going to get the elements in set A and in set B, okay, and also it includes the intersection of A and B. Okay. It corresponds to combining description of the two events using the word or. So we have now the conjunction or. So when you say or, meaning it either satisfies event A or it satisfies event B, it's part of the favorable outcome. So let's start again with our experiment, which is rolling a die. So in rolling a die, we want to find the union of the event A or B. So let's have event A. The number rolled is even. Okay. So the even numbers when you roll a die are 2, 4, 6. Okay. Now let's have event B. The number rolled is greater than 2. So this is now event B. The number rolled is greater than 2 would be 3, 4, 5, 6. Next is we want to find A or B. So meaning it should be in A or it should be in B. Then it is now A union B. So we are going to list all the possible outcomes. So I would rather start with the intersection. There's 4 and 6 in both sets. Okay, so I'm going to write first 4, 6. And what remains in set A, remember we have to empty set A, is 2. And in set B, we still have 3 and 5. So 3 and 5. So it has 1, 2, 3, 4, 5. There are 5 favorable outcomes. Okay, 2, 3, 4, 5, 6. So this is now the representation. Okay, A union B. So I hope you're able to understand. Okay, union and intersection in different ways, in sets, in Venn diagram, and now in events. So I hope that you will watch my next video called Probability of Union in Intersection of Events. So bye, and I'll see you in my next video. If you haven't subscribed to my YouTube channel, please click subscribe and hit the notification bell to receive updates of my new video. Thank you!